while you guys finish up on your one theorem, today we're going to learn the last way that you can prove that triangles are congruent. So far, we have learned that if you have two triangles that have three sets of congruent sides, with side, 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 are congruent, or you could do side, angle, side, or you could do angle, side, angle, or you could do angle, angle, side, okay? What we're going to talk about today is we're going to talk specifically about right triangles. So this only works for right triangles. So as a reminder, how you know it's a right triangle? It has a right angle. Okay? Now if it has a right angle, the two sides that make up the right angle are called the legs. The side across from the right angle, which is always going to be the longest side, is called the hypotenuse. Okay? So theorem 4.6, the last way that we can prove that two triangles are congruent is called the hypotenuse leg theorem, which just states that if you have two right triangles and their hypotenuse is congruent and they have a corresponding leg that's congruent, that's enough to prove that the triangles are congruent. So kind of in a way, you only have two sides, but you also have an angle, you know, because they both have a 90-degree angle. So you have two sides and an angle. So whenever I first looked at this, I'm like, well, we don't even need another theorem, because if you have two sides and an angle, that's one of our other theorems, right? Angle, side, side. Do angle, side, side?
Yeah. No.
No? If you did an angle, side, side, I'd probably put like a no on your paper. We can't do angle, side, side. It's a bad word.
Oh.
Yeah, I know. We can't do angle, side, side. With a normal triangle, you cannot do angle, side, side. But it turns out with right triangles, we can. And since it's a theorem, guess what we're going to do?
We're going to write it on our paper.
We're going to prove it. Mm-hmm. Now, I will tell you guys, to be honest with you, I was writing down this proof yesterday, and I was kind of trying to work it out on my own. Got some help from the book. I worked it out from the book, and I was like, I have no idea what I just did. So I had to do it again, and then I even did it a third time until it finally kind of made sense. So it's kind of a beast of a proof, but it's kind of cool, okay? So what we're starting with triangle PQR and triangle XYZ are right triangles, and the right angles are going to be at Q and Y, okay? And we know that PR is congruent to XZ, and we have PQ congruent to XY. So what we're trying to prove is that if you have two right triangles, you have a congruent hypotenuse and a congruent leg. We're trying to prove that the triangles have to be congruent, okay? Now, before we start our proof, what we're going to do here is we're actually going to construct another triangle. So what I want you to do is I want you to copy down triangle XYZ. Just maybe up here, just copy it down again. Okay, the exact same triangle, XYZ, with a right angle at Y, XY, 2 hash marks, YZ, 1 hash mark, okay? So that's just the same triangle, but here's what we're going to do. We're actually going to construct a third triangle, okay, on the other side of XYZ. So I want you guys to extend YZ out this way, okay, and then draw a line down here, and we'll call this point S. Now I'm going to draw this in a particular way. I'm going to draw this so that SY is congruent to QR. Okay, so let's do 3 hash marks on SY and 3 hash marks on QR. That's going to help us prove that. Okay, so when we're writing down our proof, although it's not actually written in the given, we are going to include that in our given. And I drew that other triangle in that way. Okay, so we'll do our statements, our reasons. Okay, got a lot of statements here. We have triangle PQR, triangle XYZ are right triangles, angle Q, angle Y are right angles, PR is congruent to XZ, PQ is congruent to XY. And then we're also going to include what we just added here, that SY is congruent to QR. Okay, and all of that's going to be in the given. Now let's kind of talk about a game plan here. Remember that the end game plan here is to prove that these two triangles are congruent. The game plan here, I want to start with this triangle here, this triangle XYS, okay? I have enough here to prove that this triangle XYS is congruent to this triangle. Because look, I have a side, an angle, although I didn't mark it, you have a right angle and a side. See how I can prove that these two triangles are congruent by side, angle, side? Yes? Okay, let's do that. Let's take one step at a time. So I know that triangle PQR is congruent to triangle XYS because of side, angle, side. I already have enough to prove that. Okay, so I have these two triangles are congruent. Okay, so I'm just trying to tie a bunch of this stuff together. So, if I know that, I guess I should mark this here, okay? Mark the wrong side. Okay. Okay, if I know that these triangles are congruent, might be nice if I could prove that these triangles are congruent. So I can't yet prove that these are congruent, but if this is congruent to this, okay, and if these are congruent, then maybe I can tie them all together. So I need to be able to prove that these two triangles right next to each other are congruent, okay? So right now I have a side, I have an angle, but that's kind of it, okay? What I need, okay, I need either some more sides or some more angles. So, but here's the thing. I know that this triangle and this triangle are congruent, so all of its corresponding sides are congruent. So I already have the sides and that angle marked, but let's go ahead and let's say the hypotenuse is also congruent. So let's say that, okay, let's say that PR is congruent to XS. PR is congruent to XS. How do I know the hypotenuses are congruent? Congruent parts of congruent triangles. Okay, so since that's marked with 1, I can go ahead and mark that with 1. So now I have a side, side, and an angle. Can I do angle, side, side? No, angle, side, side, can't do that. Okay, I need another angle. It'd be nice if I could have these angles right here, right angle S and angle C. What kind of triangle is the big triangle? It's an isosceles triangle, isn't it? And remember from what we did on Monday? If these sides are congruent, what do I know about these angles? They're also congruent, right? So, I know that angle S is congruent to angle Z, and that was called the isosceles triangle theorem. Okay, well now I have an angle, and a side. You can actually go either way. You can do angle, angle, side, or angle, angle, side. But I now have enough to say, okay, these two triangles are congruent. I know that triangle XYZ is congruent to triangle XYS because of angle, angle, side. But if I look at step 2 and step 5, angle PQR is congruent to angle XYS, and angle XYZ is congruent to XYS. I have these two triangles that are congruent to the same thing. What can I conclude? They'd have to be congruent to each other. If this is congruent to something and this is congruent to the same thing, they'd have to be congruent to each other. You guys remember what that is? Not reflexive, Transitive. Good. So we know that triangle XYZ is congruent to triangle PQR by the transitive property of congruence. Told you guys that was kind of a beast of a proof. I couldn't come up with that one on my own. I had to get help from the book and do it like 3 times, and it still can be a little confusing. Okay. And we do have more proofs today, but not like that. They're going to be simpler proofs. Okay. Let's go ahead and let's get this glued into page 59. This is section 4.6, and it's congruence with right triangles. Okay, now here's the thing. With all of the other triangles, usually I would tell you in your proof, if you're going to use side, 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 somewhere in your proof you have to say side congruent to side, side congruent to side, side congruent to side, or side, angle, side, and so on. You should have 3 separate statements that say that. With hypotenuse leg, it might at first glance just say, oh, well, this is great. This is going to be easier because all I have to do is prove that the hypotenuse is congruent and the leg is congruent, which is kind of true. But you have to remember that hypotenuse leg only works with right triangles. So when you're using the hypotenuse leg theorem, you have to prove or say in your proof, these are right triangles. And how do you know they're right triangles? So that has to be included as well. So although you're not having to prove 3 sides or angles, you have to say, okay, yes, it's a right triangle. Since it's a right triangle, the hypotenuse is congruent and the leg is congruent. We had a little bit of a debate last hour about what the plural of hypotenuse is, and I still haven't figured it out. So we're going to go back and forth between hypotenuses and hypotenusi, and then I'll figure it out. Let me know. Okay? All right, so number 1. The given BE, side BE, bisects AD at C. BE bisects AD at C. Okay, and then side AB is perpendicular to side BC. DE is perpendicular to EC. And AB is congruent to DE. Quite a beast of a given there. We are wanting to prove that triangle ABC is congruent to triangle DEC. Okay, here's our picture. Kind of like a sideways bow tie looking thing. And we'll label it A, B, C, and then D, E. Okay, like always, let's mark our diagram with everything I know, whether it's from the given or things that we know from the given. So I know first that BE bisects AD. Now you have to pay really close attention to what order it gives you this information. It says that BE bisects AD. This, okay, is the one that's being cut in half. Right? BD bisects AD. This is the side that's being cut in half. So I know that AC is congruent to CE. We also know that AB is perpendicular to BC. So I know that angle B right there is a right angle. And then I know that DE is perpendicular to EC. So that angle E right there, that's also going to be a right angle. And then finally, I know that AB is congruent to DE. So what we're looking for today is we're looking to see if I can use hypotenuse leg. If you can use hypotenuse leg, 3 things have to be true. It has to be right triangles. I've got right triangles. You have to have the hypotenuse congruent. and you have to have a like congruent. I have all that. Now here's the thing. You have to say all of that in your proof, okay? So let's start out with this one. So let's start with our statements and our reasons. I'll copy down. Actually, you know what? We're gonna, for time purposes, since we already copied it out once, we have our given, all of that lovely information there. Now here's the thing. If you're going to use hypotenuse leg, you first have to say, these are right triangles. But here's the thing. What has to be true if they are right triangles? It has to be right angles. Have I said that yet? No. So we got to say that first. The first thing we have to say in my second statement is going to be that angle B and angle E are right angles. How do I know that angle B and angle E are right angles? Definition of perpendicular lines. Okay, well, I mean, I have two triangles, okay, that have right angles in them. That's enough to say, okay, I know that they're right triangles. So I know that triangle ABC and triangle DEC are right triangles. And your reason for that, that's just simply the definition of right triangles. Right triangles are triangles that have a right angle. So if we've said they have a right angle, there we go, they're right triangles. Okay, so I've got that taken care of. I said I have two right triangles. Now I have to say the hypotenuse is congruent to the hypotenuse. Have I said that yet? No. What is the hypotenuse in both triangles? Which sides are the hypotenuses? AC and CD. Okay, and I have them marked, but I haven't said it yet. But I know that AC is congruent to DC. What told me I could mark them that way? Yeah, it said that it bisects it, right? So this would be the definition of a segment bisector. Okay, so I've said the right triangles. I've said their hypotenuses are congruent. I need to say that their legs are congruent. Have I said that already? I did, right? In the given? Yeah, in the given. Look, AB is congruent to D. I already said that. You don't have to say it again. So if I've said they're right triangles, their hypotenuses are congruent, and their legs are congruent, that's enough to say triangle ABC is congruent to triangle DEC by hypotenuse leg. So the big thing here, you have to prove in your proof that you're looking at right triangles. And then the hypotenuse and the leg. Okay, let's do one more of those. So number 2, our given CD is congruent to EA and AD is the perpendicular bisector of CE. AD is the perpendicular bisector of CE. We want to prove that triangle CBD is congruent to triangle EBA. And here's what our picture looks like this time. We have intersecting lines like that, and then we'll connect that pin. Okay, this left point is going to be A, the middle will be B, this bottom will be E, the top will be C, and the right will be D. Okay, we want to mark our diagram, of course, so we know that CD is congruent to EA. Then it tells me AD is the perpendicular bisector of CE. So the first thing, it's perpendicular to CE. So that tells me that these two right here are right angles, which is good. It tells me we're dealing with right triangles. Now pay close attention once again to the order. It says AD bisects CE. So CE is the one that's being cut in half. So CB and BE are going to be congruent. So it's kind of easier to see the game plan here because I need to say that they're right triangles, which I can see that they're right triangles, right? Because perpendicular lines. I need the hypotenuse and I need a leg. Okay? So let's start our proof here. Statements, reasons. I shouldn't be being a bad example here and being lazy. So let's copy down our given. CD is congruent to EA. AD, perpendicular bisector of CE. Because of the given. Remember, in order to say hypotenuse leg, you first have to say, these are right triangles, and I haven't said that, and I can't really say they're right triangles unless I've said that they're right angles, but I know they're right angles. So to name these, maybe we could call it angle CBD and angle EBA are right angles. How do I know they're right angles? Not right angles, definition of? Yeah, there we go. Perpendicular lines. Perpendicular lines create right angles. And kind of like the last one, I have two triangles that have right angles, so I know that they are right triangles. So triangle CBD and triangle EBA are right triangles, and that is definition of right triangles. Okay, so I've got the right triangle part taken care of. Now I need the hypotenuse. Have I said that the hypotenuse are congruent? It was in my given, right? CD congruent to EA. I already have hypotenuse covered, but I need the legs. What are the legs that are congruent? So I already did the hypotenuse. What are the EB and CB? Yeah. So EB is congruent to CB. And how did I know they were congruent? Yeah. Definition of segment bisector. Okay, well I said the right triangles. I said their hypotenuse are congruent and their legs are congruent, so that's enough to say. What is going on here? Number 5. Triangle CBD is congruent to triangle EBA. EBA because of hypotenuse. Okay, so most of your homework is going to be proofs and kind of working through proofs like that. but you are going to have a few examples that are just going to have you apply this idea that if two triangles are congruent by hypotenuse leg, it means the triangles are congruent, but specifically, their hypotenuse are congruent. Their legs are congruent. So, for number 3, let's say I have these two triangles. We're going to draw two right triangles here. So a right triangle right there, and a right triangle right here. Now, in this right triangle, on this left-hand one, let's say that this leg on the left is x, and the hypotenuse is x minus 2. And in the other triangle, the hypotenuse is 2y, and that leg is going to be y plus 3. So it's basically saying, okay, if these triangles are congruent by hypotenuse leg, what do I know about the legs? They're congruent. So I know that x equals y plus 3. They're the same. And what do I know about the hypotenuse? They're also congruent. I know that x minus 2 equals 2y. Now, these ones are going to be a little challenging because, can I solve either one of those equations? No. Going back to algebra here. Who remembers how to solve a system of equation by substitution? Okay? Pretty easy to do. We've actually kind of done substitution a lot here. Okay? If x equals y plus 3, I could use x or I could use y plus 3. So in the other equation, instead of x, substitute y plus 3. So it's going to look like this. So we're going to plug that in right here. We're going to do y plus 3 instead of the x. And then we're going to keep the minus 2 equals 2y. See, I only have y's left? And I can solve for y. So 3 minus 2, give me y plus 1 equals 2y. Subtract y. And we get y equals 1. But I also need to find x. How can I find x? Exactly. Yeah. X equals y plus 3. Well, if y is 1, we're going to take 1 plus 3, which would give me 4. Okay, you're going to have 2 of these in your homework, and they are set up almost exactly like this. Okay? Let's do one more of those to end with today. All right, so number 4. Draw 2 more right triangles here. Okay, so we got our 2 right triangles. Okay, that first triangle, the hypotenuse, is going to be 3y plus x. That bottom leg, we'll call it y minus x. The second triangle, let's do the hypotenuse is y plus 5. And then that leg is going to be x plus 5. Okay, who could set up one of my 2 equations? Karina? Very good. Those are the legs. The legs are congruent. What would the other one look like? Y plus 5 equals 3y plus x. Okay, now to do substitution, one of your equations has to be solved for one of the variables. So probably the easier thing to do here is take this first equation, solve it for y. So add x to both sides, and we'd have y equals 2x plus 5. Now we're going to have to substitute that into the second equation. But if you look at the second equation, see how you have y's over here and y's over here? It might be easier if all your y's are in the same spot. So what I might do for that second equation, I might call it 5 equals 2y plus x. That way I'm only having to substitute that y in one time. So now what I'm going to do is I'm going to take y equals 2x plus 5. And I'm going to plug it into that second equation. So we're going to do 5 equals 2. Instead of y, we'll plug in 2x plus 5. And you still have that plus x. And then to solve for x, we'll distribute the 2. So 2 times 2x would be 4x. 2 times 5 would be plus 10, which equals x. 4x plus x would give me 5x. Plus 10 equals 5. Subtract 10 from both sides. Divide by 5. We get x equals -1. And then to finish it off, plug in your x. So y equals 2 times -1 plus 5, which would be -2 plus 5, which would be y equals 3.